and good day everyone. I am Associate Professor Dr. Mazura Jusoh. The title of my research is Multiple Probes Cryo Concentrator for Highly Preserved Cucumber Juice Concentrate Production. Cucumber.
There is very high demand for cucumber juice in Malaysia and globally. Cucumber is popular because it has high antioxidant properties. It also contains various nutritional benefits, and it is scientifically proven to fight against cardiovascular diseases and cancers. Cucumber has various industrial applications, including in cosmeceutical, pharmaceutical, food and beverage processing. Before being used in all these applications, it needs to be concentrated. But all the TPC and other nutrients needs to crucially be well preserved. There are a few conventional concentration methods available currently, both thermal and non-thermal. Evaporation is a thermal operation and reverse osmosis is non-thermal. Both processes can remove pure water from a solution. Typically in juice concentration industry, evaporator will be used. In evaporation, the juice is heated to remove the water content as required, for example, in a single effect evaporator. In here, the juice will be fed at the bottom of the column and heated with steam for a designated time to achieve the desired concentration. It is hard to maintain the important quality parameters including color and appearance, flavor, which consists of taste and aroma, texture and cloudiness, and bioactive compounds availability like phytochemicals or phenolics. Reverse osmosis is a process to remove pure water by pressuring the concentrated solution. Thus, the water movement will move from the higher concentrated solution to the less concentrated one through a membrane that will let only water molecules to pass through. It can remove pure water as well, but it is unable to achieve higher degree of concentration compared to evaporation due to its high osmotic pressure limitation and membrane fouling with the soluble materials in the solution on the external surface or within the pores of the membrane. Due to the shortcomings of the existing conventional concentration and water removal methods, we propose to use freeze concentration, which is a non-thermal process, to avoid active compounds and nutritional loss and degradation. Freeze concentration is a process that removes water content in a juice or solution by freezing it into ice crystals at sub-zero temperature. The concept is to form and grow high-purity ice crystals which expel the impurities while forming its crystal lattice. The leftover solution will then have less water content, hence producing a concentrated liquid in the end. The quest to find the perfect PFC system design is still continuing to improve its performance. Looking at this chart, we can see various design aspects to be considered when designing the progressive freeze concentration system. In our MPCC, the design characteristic focused on is the surface where the ice crystal will progressively form. To date, no researcher has looked into producing and forming the ice crystal layer on a probe or a set of probes. The advantage of designing the surface as probes is that the surface area can be maximized in proportion to the vessel the sample is fed. The scaling up is also very much easier and can be done at any size required with a suitable number of probes. In our research, the cucumber will first be put through a juicer. The juice is then fed into the multiple probe cryo concentrator ice crystallizer to carry out the concentration process. The concentrate will then be characterized and analyzed, and this concentrate, which is reduced in volume and highly concentrated, can be used as food flavorings and active compounds in cosmetics, pharmaceutical products, and many more. The schematic diagram of the MPCC is shown here. The detailed explanation of the apparatus parts and setup will be explained in a video after this.
So this is the multiple probes cryo concentrator, or we call it MPCC. So the setup mainly consists of this set of 5 probes, which is capable to rotate 100 degrees Celsius interdirectively. And this probe is actually cooled by a cooling system with R22 coolant gas supplied in the inside hollow shape of the probe. So this is actually the cooling system that is attached to the probe. And the other part of the MPCC is the cylindrical stainless steel solution tank or vessel. And this tank is actually the one that will hold the cucumber juice when we run the experiment. And this tank is actually, it comes with a jacket where we supply the coolant liquid, which consists of ethylene glycol and water in 50-50 volume percentage. And at the bottom of this tank, there is actually a stirrer to keep the solution or the juice inside moving.
The freeze concentration process carried out by the MPCC on the cucumber juice yielded ice layer on the probes as shown here. Based on operating parameters, increment in the concentration can be achieved successfully. The results have been reported in 3 publications so far. MPCC has high capability to remove water contents from any solution, thus the extent of utility is very large. The MPCC technology can be used in various applications requiring water removal, such as desalination to produce drinking water, purification of rainwater for drinking purpose, concentration of dairy products for powder production, concentration of other fruits, plant and herbs extract for further processing like spray drying, and concentration of other heat-sensitive solutions and materials. As strategies for commercialization, it is planned to introduce MPCC as an economically attractive, safer and improved system to companies processing fruit juices and liquid food products. We will promote it as a system that can give more efficient heat transfer at a larger production scale and great efficiency. The companies should also know the unique MPCC design that minimizes the detrimental effect on nutrients in sensitive solutions and liquid foods. It is suitable for sophisticated process that fits the requirements of both the industries and the consumers. As this MPCC can be used in various applications, we see the potential market with numerous companies, including Nestle and Frito-Lay. We hope our little effort will help human race to have better nutrition and consumer products and higher chance of having a sustainable life. Thank you.